All right, let's get right into it. Today, we're tackling one of the biggest, most mind-bending questions in all of physics. And we're going to do it with a framework that might just change how you see reality itself.
So here's the puzzle that's been driving physicists crazy for about a century. You've got two particles, right? They're linked. Then you separate them, even by light years. The instant you measure one, you know the state of the other. Instantly. How? How is that even possible?
Even Einstein hated this idea. He famously called it spooky action at a distance because it looked like it was breaking the ultimate rule of the universe. Nothing travels faster than light. So what's going on? Is reality just spooky? Or is there something deeper we're missing?
Okay, to get a handle on this, we're going to use the TCGS framework. And it all starts with one really powerful idea. The map is not the territory. What if all this quantum weirdness, this spookiness, isn't a property of reality itself, but just a distortion, a weird spot on the map we're using? So in this framework, the actual territory is something called counter space. Now, try to picture this. A single, timeless, four-dimensional object that holds every single moment, past, present, and future, all at once. It's not a story unfolding in time. It's the whole book, from cover to cover, existing simultaneously. This is the deep reality.
And us? Where are we in all this? Well, we live on what's called the shadow manifold. That's our 3D world, the one we see and touch. But here's the twist. It's not the real thing. It's just a projection, like a shadow cast on a wall by that deeper 4D counter space. We're living in the shadow of reality. And this slide really nails the difference. The standard view says our 3D world is all there is, and quantum weirdness is just a fundamental, bizarre feature of it. But the TCGS view says, no. Our world is a shadow, and all that quantum weirdness, it's just an artifact, a strange effect that happens when you project a higher dimensional object onto a lower dimensional surface.
So let's bring it all back to entanglement. If our world is a shadow, what does that mean for our spooky action? Well, this is where it gets really elegant. TCGS suggests it's not action at all. It's structure. It's a direct look at the hidden geometric connections in that deeper reality.
Here's how it works, step by step. First, shared ancestry. Our two entangled particles come from the exact same point in that 4D counter space. Think of them as twins. Second, because of that shared origin, they have a pre-existing correlation. Their properties are linked by their geometric history. So third, when you make a measurement, it's just a readout. You're not magically changing the distant particle, you're just reading the information that was encoded in their shared connection from the very beginning. And just like that, the problem with the speed of light just dissolves. There is no faster-than-light signal because no signal is ever sent. The connection was always there, a permanent, timeless feature of the geometry of counter space. The spookiness is gone.
Now, I know what you might be thinking. This is a pretty radical idea. Does it have any connection to the real world? And the answer is yes, absolutely. This isn't just a philosophical concept. It's grounded by experimental results. We're going to look at two very different experiments that serve as anchors for this new map of reality.
Just look at this table. The two anchors couldn't be more different. On one side, we've got a relatively huge nanoparticle with thousands of atoms, observed over milliseconds. On the other, a single helium atom, observed on the timescale of attoseconds, which is an absurdly short amount of time. And yet TCGS shows how both of these experiments point to the very same underlying reality.
Let's start with the big one. An experiment showed quantum effects in a nanoparticle made of over 7,000 atoms. That is massive for the quantum world. And what this suggests is that the shadow of this particle can remain quantum, or fuzzy, as long as its connection to counter space is preserved. This is a key insight the theory calls projection rigidity. Now let's jump to the other extreme. Scientists measured a time delay of just 232 attoseconds when an electron was stripped from its atom. To put that in perspective, there are more attoseconds in 1 second than there have been seconds in the entire age of the universe. The TCGS framework says this tiny delay isn't a travel time. It's a direct measurement of the geometric connection between the particles in counter space.
So, here's the bottom line. These two experiments, operating at completely different ends of the scale, one huge and slow, the other tiny and fast, both point to the same conclusion. This idea of a geometric connection in counter space seems to be a consistent feature of our reality, no matter where you look.
Okay, so we've reframed entanglement, but what about that other big quantum mystery, the collapse of the wave function? You know, the idea that a particle exists in many states at once until you measure it, and then it suddenly collapses into one? Let's see how the TCGS map handles this one. Instead of a collapse, TCGS proposes something called projection rigidity. It's a beautiful idea. Imagine the shadow of an object on a wall. If the light source is fuzzy, the shadow is blurry. But as the object interacts with its environment, more photons bouncing off it, for example, its shadow in our world sharpens, it stiffens, and the quantum fuzziness seems to disappear. So here's the choice. The standard view talks about a mysterious collapse where possibilities just vanish into thin air. The TCGS view says nothing vanishes. The interaction with the environment just causes the projection to become more rigid, narrowing the slice of information we can actually see from counter space. It's not magic, it's just a change in perspective.
So let's pull this all together. What does this new map tell us? It says the line between the quantum and classical worlds isn't real. It's just an effect of that projection rigidity. It says collapse is an illusion. And it says time itself isn't a river we're flowing down, but more like the act of flipping through the pages of a book that's already been written. And entanglement, that's the binding holding all the pages together.
And that leaves us with this final massive question. If our entire world, our entire experience is just a shadow of a deeper, unchanging, timeless reality, what does that actually mean for us? For our understanding of who we are, of our past, of our future? This map, it doesn't give us all the answers, but it points toward a whole new continent of reality, just waiting to be explored.